the limit of the greatest integer function as x approaches 0 from the left and from the right. Well, what is the greatest integer function? If we go back and read the definition, then we can try to graph this, saying the greatest integer function is the largest integer smaller than or equal to x. So let's just start off by plotting some points. When x is 0, then the function is 0. What about when x is 0.1? The largest integer smaller than 0.1 is still 0. What about 0.2? It's still there. What about at x equals 1? At 1, suddenly we're going to jump up here to this number. So the graph should look something like this. And then there's an open circle at 1. Because every number between 0 and 1, the greatest integer smaller than that is the number 0. Once we get up here to 1, the next point to worry about is 2, because the function's going to stay flat. And then it's an open circle. And you can see at 2 it's going to jump up here, and it's going to go over. And it kind of looks like stairs. So you'll sometimes hear this referred to as the stair-step function. The stair-step function. And I would say this is one of those you need to kind of remember what it looks like, because it's hard to graph, hard to remember. But if you just look at it, then it's easy to see. Well, let's talk about the problem that we were asked. Find the limit as x approaches 0 from the left and from the right. Well, from the right, we've got it drawn here. What does the function appear to be approaching from the right? From the right, it's approaching the number 0. Well, where's the function going to be at down here on the left? What if we're at negative 0.1? The largest integer smaller than negative 0.1 is down here at negative 1. So we're going to have an open circle here and something that looks like this. So the largest integer here is going to be negative 1. So if we look at this limit, this function is approaching the number negative 1. So the limit from the right is 0, from the left is negative 1. What's the limit? The limit doesn't exist. Is the function continuous at 0? No, it's not. Where else is the function not continuous? It's not continuous at the number 1. It's not continuous at the number 2. It's not continuous at the number 3. It's not continuous at every integer along the way. So this is a function that has lots of places where it is continuous, but a lot of places that it's not continuous as well, because the function is not continuous at every integer. What type of discontinuity is there at every integer? There's a jump discontinuity, because the function's jumping from down here at the number 1 up to the number 2.